See, my ultimate aim is to evaluate theta. The centripetal force F is mv square divided by r. So this is the expression for maximum height. And in the problem, so a very interesting problem solved on angle of banking. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University College. Let us start a new session, solve problems from the chapter Motion in Two Dimension, which is also referred as motion in a plane. The first one, what is the angle of banking? I have to calculate the angle of banking for a curved road of radius 180 meter, suitable for a maximum speed of 30 meter per second. If the radius is 180 meter and the optimum speed is 30 meter per second, I have to calculate the angle of banking. Calculate the maximum speed to be maintained when the angle of banking is 30 degrees. So in the first case, the first part of the problem, radius is 180 meter and the maximum speed is 30 meter per second. Given this data, I have to calculate the angle of banking. So we know that tan theta is V square divided by RG. So V is given, radius is known. So tan theta is V square, 30 square, radius is 180 into G. Approximately I take as 10. So which is 0.51. So tan theta is 0.512. On simplifying, theta is tan inverse 0.512, and the simplification says this is nearly 27 degrees. The next part of the problem, I will have to calculate the maximum speed when the angle of banking is 30 degrees. Now, theta is 30 degrees. So, tan 30 is V square by RG, or V square is tan 30 into 180 into 10. So on simplification, V turns out to be 32 meter per second. So a very interesting problem solved on angle of banking. Now, the next one. A bullet fired from a rifle. So a bullet which is shot from a rifle attains maximum height of 50 meter and crosses a range of 200 meter. I will have to find the angle of projection. So maximum height attained by the bullet is given to be 50 meter and it is crossing a range of 200 meter. I have to calculate the angle of projection. So now let us recall the expression for maximum height, where we told maximum height is u square sine square theta divided by 2g. So this is the expression for maximum height, and in the problem maximum height is already given. So 50 equals u square sine square theta divided by 2g. I call this equation 1. And what is the expression for range? So R is u square sine 2 theta by g. Now, can I not rearrange sine 2 theta? So sine 2 theta is rearranged and this is u square 2 sine theta cos theta divided by g. The value of range is given. So 200 equals u square 2 sine theta into cos theta by g. See, my ultimate aim is to evaluate theta. So I am rearranging terms and I call this equation 2. So now equation 1 divided by equation 2 so that I arrive at, yes, so this is 50 by 200 is sine theta by 4 cos theta on dividing equation 1 by 2, or this turns out to be 1 by 4 is 1 by 4 tan theta sine by cos, or tan theta is 1, which means theta is 45 degrees. So we get the value of theta, angle of projection, as 45 degrees. The next one. A train of mass 10,000 kg moving at 72 kilometers per hour rounds a curve whose radius of curvature is 200 meters. Calculate its acceleration as well as calculate the centripetal force. So there is a train whose mass is 10,000 kg. So the mass of the train is given. It is moving with 72 kilometers per hour. So the velocity is 72 into 1000 divided by 60 into 60. So that I can convert that into meter per second. Meter per second. And the radius is 200 meters. The first part I will calculate the acceleration where I use A equals V omega. But we know also V is omega times R. So omega is V by R. Relationship between linear velocity and angular velocity. V equals omega R, or omega equals V divided by R. So substituting here, A is V into V by R, or A is V square by R. So this is 20 square divided by 200. So this acceleration turns out to be 2 meters per second square. Now the centripetal force F is mv square by r. We have studied in our concept class the centripetal force F is mv square divided by r, or this is 10,000 into 20 square again by r. So this is equal to 20,000 Newton. So this is the centripetal force. The next problem, students. A train is moving around a curve of 52-meter radius, and the distance between the rails is 1.2 meter between the rails. How much should the outer rail be raised above the inner one so that the train running at the rate of 45 kilometers per hour may not skid? So collecting the data first, the radius is given to be 52 meters. And the distance between the inner edge and the outer edge, I call the height, is 1.2 meter. The velocity of the train is 45 into 1000 divided by 60 into 60, which is 12.5 meter per second. First, I will calculate the angle of banking here. So we know tan theta is V square by RJ. So tan theta is 12.5 whole square divided by 52 into 10, from which we get theta is nearly 17 degrees. Now I have to calculate the height to which the core is raised. So h dash is h into sine theta. This is 1.2 into sine 17 degrees. Again, use your Clark's table. So this turns out to be 0.35 meter. So students, we have solved simple problems from the chapter two-dimensional motion. Next session, I come up with few more problems. Until then, have a nice time. Thank you.